Welcome to AP Statistics. We are in Unit 1, Exploring One Variable Data. Today we're going to talk about Topic 1.7, Summary Statistics for a Quantitative Variable. So when working with quantitative variables, we can make a graph and talk about the data we collected as a whole. We learn to talk about the shape, the center, the spread, possible outliers. So we can describe the data, we could summarize the data, we can analyze the data using words. So many fun things. But we could also describe, summarize, and analyze the data using numbers. Any number that describes or summarizes a set of quantitative data from a sample is called a statistic. Any number that describes or summarizes a set of quantitative data from a population is called a parameter. Let's talk about that a little bit more. Statistics versus parameters. For all intents and purposes, they really are the exact same thing. However, if the value is describing a set of data that came from a sample, which is a subset of a population, we call that statistics. It's actually really easy to remember. S for sample, S for statistic. So if it came from a sample and it describes that sample, it's a statistic. If the value is describing a complete set of data coming from the entire population, we call that value a parameter. So again, pretty easy to remember. If it came from a population, it's called a parameter. I'll just give a really quick thing here. The mean, right? Everybody should know what the mean is. We're going to talk about it in this video, but the mean is the average of a set of data. If it's a sample of data, like just looking at 10 high school kids, then the mean is going to be a statistic because it's the mean of that sample. Whereas if we found the mean of all high school kids, all of them, not just a sample of 10, the entire population of high school kids, the mean of that entire population would be known as a parameter. It's still a mean. It still gives us an average, but it's where it came from. It's a statistic if it comes from a sample, a parameter if it comes from a population. And to be honest, most data comes from samples because measuring an entire population is oftentimes impossible. So let's assume everything we talk about today is from a sample, which makes everything we look at today a statistic. So there are ways that we could use statistics to summarize data. We could use a statistic to summarize the center of data, other positions in the data besides the center. We could use statistics to talk about the spread of the data, and we can even use statistics to identify outliers in the data. So there are no statistics that directly tell us about the shape of the data. That's not like we could say, oh, that's a shape 6. No, we use words like skewed left, skewed right. So shape, you got to use words. But when we talk about center, spread, variability, outliers, now we can actually use numbers. All right, let's first talk about statistics that summarize the center. Statistics that summarize the center of your data. There are two of them, the mean and the median. Now, the mean, everybody already knows, at least you should. It is the average of all of the values. Now, in this class, the symbol we use for the mean of a sample is X bar. It's literally pronounced X bar. It's an X with the bar over top of it. And this is a formula for X bar. It's kind of a confusing formula to most kids that are pretty new to this. But just think back, right? To find an average or a mean, all you do is add all of your values together and divide by how many values you have. So typically N is the number of values we have. And this symbol right here, this funky looking E thing, that's a sigma notation. That's the summation symbol. So that's just a fancy math symbol that says add all of your values together. So don't get hung up on that symbol. Just know that it means add all of your values together. And then we need to divide by n. But remember, in math class, dividing by a number is the same thing as multiplying by its reciprocal. And the reciprocal of n is 1 over n. So if we add up all of the values, which is essentially what this is saying, and then divide by the number of values, which is multiplying by 1 over n, we get the mean. Don't worry too much about this funky looking formula. To be honest, our calculator is typically going to calculate it for us anyway. Let's talk about the mean really quickly here. The mean takes every value into account. Every single number in your data set goes into calculating the mean, which means it's easily impacted by outliers. If there is one really enormous high value, the mean is going to move a little bit higher because of it, because it's got to treat that one value, even if it's only one of them, it's got to treat it fairly to all the others. And it's the same thing can be said the other way. If all of your values are in the hundreds, but you have one value that's really down in the single digits like 3, that one really, really low value is going to pull the mean down closer to it, okay? So with skewed data, it will move towards the tail. Let me draw a picture to help you understand this. Remember, when data is skewed, there's a rough picture of skewed data, it means there's more data to the left, less data to the right. So these values on the right are big, really big numbers compared to all the other values that are down here. But the mean has to take those values into account. So that means that the mean might gravitate a little bit towards the tail to the right because it has to compensate for those numbers. So the mean doesn't always go into the tail, but it just goes in that general direction. Again, if you think about it like this, like the opposite, I'm sorry, I'm kind of running out of room here. The opposite would be if you're nice and symmetric. If you're nice and symmetric, you kind of tail off on both sides, then the mean's going to be smack dab in the middle. It's going to be right in the middle. The bottom data is going to balance out with the top data. But when you're unbalanced, the mean is going to go towards the tail because those values are going to influence it, pull it closer, okay? If you don't believe me, just do something like this. If you find the mean of 3, 5, 5, and let's see here, 7. Well, if you don't believe me, but just trust me, the mean of this data is 5. But if I were to add a 6th value, like 1,256, now all of a sudden, the mean is going to jump way up here somewhere in the middle, and it's not going to be anywhere near these values, nor is it going to even be near this value. It's going to move to the right because of that one really, really big outlier. All right, we'll talk a little bit more as we go here, but let's talk about median now. So the median is the absolute dead center of your data. The median does not care about the value of the data. It just cares about being the middle value. So like if I have 5 pieces of data, the median doesn't care what these numbers are. These numbers could be anything. It doesn't care what the numbers are. It just wants to be the middle value. So this could be a 1, this could be a 3, this could be a 5, this could be a 17, this could be a 22. And it just wants to be in the middle. It doesn't care what those numbers are. It just wants to be that middle value, okay? Now, when you have an odd amount of data, the median is smack dab in the middle. Like my example here, there are 5 values. The median is the value smack dab in the middle, 2 above, 2 below. When you have an even amount of data, let's just say we had 6 data values. And again, I'm not putting numbers down because the median doesn't care what the numbers are. It just wants to be in the middle. The middle is right here. So it's actually not one of the values. It's directly in between the 3rd and the 4th values. This is the 1st, this is the 2nd, this is the 3rd value, 4th, 5th, 6th value. Again, who cares what the values are? The median just wants to be in the middle. So in this sense, since there's 6 of them, it wants to be right in between the 3rd and the 4th value. So if the 3rd value is 10 and the 4th value is 12, then the median is going to be 11. It's going to be the average of those middle 2 values. It's not going to be 10, it's not going to be 12, it's going to be the number in between them, which is 11. Hopefully that makes sense. All right, now, there is no formula to find the median. It's a process. You have to put your data in order from the smallest to the largest, and then you simply find the value that is in the middle, right here in the middle. That's your median. But there is a formula that could locate the middle position. So I can't emphasize enough, this is a formula not to tell you what the median is. It's a number that helps you find where the median is at. So let's use it. Practice this real quick. If I have 5 pieces of data, and I say, okay, I got them in order. Here's the 1st, here's the 2nd, here's the 3rd, here's the 4th, here's the 5th. Okay, where's the median? Well, 5 plus 1 is 6. 6 divided by 2 is 3. That tells me that the median is not 3. The median is the 3rd value. So here's the 1st value, here's the 2nd value, there's the 3rd value, there's the median. So again, if my numbers were 1, 3, 5, 17, 22, the median would therefore be 5, the 3rd value. Now let's just do one more example. If you have 6 values, 6 plus 1 is 7. 7 divided by 2 is 3.5. So what that means is that the median is right in between 3 and 4. So here's the first, here's the second, here's the third value, here's the fourth value. So right here, right at 3.5 is where the median is. But once again, it's the position of the median, not the number. So then you got to look at your data, right? So if my third value is 10 and my fourth value is 12, then the 3.5 value, the value directly in between 3 and 4, in this case would be 11. There's my median. Now, the nice thing about a median is it's not impacted by outliers. I know I'm getting really crazy here with my space, but again, think about if I have 5 values. Right here is the median, no matter what the value is. This could be 6, 8, 14, 17, 85. Obviously, this 85 is probably an outlier. It's not even close to the rest of the data, but that doesn't change the median. I could even make this a bigger outlier by making it 97, or I could make it an even crazy outlier, 1,142. But guess what? The median is still in the middle at 14. So it's not impacted by outliers. Okay? Also, by definition, the median has 50% of values below it, and it has 50% of values above it. That's the median. All right, now, how do you find the median and the mean in a data set? Do we do it by hand? Nah, that ain't cool. I mean, of course we could, but the cool way is use the calculator. Now, I'm being a little bit facetious here, but seriously, you could always find the mean and median by hand. You could take your values, add them all together, divide by how many there are, boom, you got your mean. To find the median, you got to put them all in order, and then you got to find the middle. Okay, but that takes too long. We're advanced. We have technology. Let's use our calculator. All right, so here is a sample of 13 females that were asked to give their commute time to work in minutes. How many minutes does it take you to get to work? All right, so to find the mean and median by hand, well, let's talk about the mean first. To find the mean, we have to add them all together and divide by 13. I don't want to waste my time doing that. To find the median, I got to figure out which one's in the middle. Now, once again, that formula I showed you earlier for the median is n plus 1 divided by 2. Doesn't tell you what the median is. It tells you the position of the median. So 13 plus 1 is 14. 14 divided by 2 is 7. That means the median is the 7th value. 3, 4, 5, 6, 7. So there's the median. But imagine if we had a huge data set. You definitely don't want to do that by hand. This is where the calculator comes in. All right, so here we go. On your calculator, the first thing we have to do is put the data into the calculator. So to do that, I'm going to go nice and slow. Stat, hit the stat button. Hit the edit right there. It's under the edit menu, and the first option is edit. So at the top, we have edit, calc, and stats. Well, we want the edit menu, and we want to edit. So edit, edit. Then you have a couple, probably 6, but it all depends. You have a couple different lists. I do not care what list you put your data in. You just have to put your data in one of the lists. I use list 2. So I put my data in. It does not even have to be in order. It just has to all be there. 5, 8, 11, 15, 15, 15, 22, 23, 23, 24, 29. And I'll keep scrolling down here. 35, 45. All my data is there. Once you're done entering all the data, second mode, get out of there. Quit. All right, now we're going to go stat. This time we're going to slide over to calculate. That's the middle command. And we're going to choose one variable, stats. We only have one variable here. How many minutes does it take you to get to work? Click on that. Now, where it says list, you want to enter in the list where your data is. So if you did use list 1, you're going to hit second number 1. You'll see the little L1 above number 1. So second number 1 is where you get list 1. If you use list 3, second number 3. Well, I use list 2. So second number 2 is list 2. Leave the frequency list blank. We'll talk more about that later, but for right now, you're always going to leave that blank. And then go ahead and hit calculate. Now, at the very, very top is X bar. That is our symbol for the mean. How cool is that? So 20.769 is the mean. 20.769 minutes is the average time it took these women to get to work. And then again, we could scroll down here. Oh, that's the thing I should definitely make sure I say. There's a couple other things on the screen here, but we'll talk more about those later. Scroll down, scroll down, scroll down, scroll down, and boom, there we have the median. There is no symbol for the median. The calculator just shortens it to MED. Yeah, we don't really have an official symbol for the median. We just call it the median. And the median is 22, which we already knew because we calculated it, but just in case, the median is 22, in case you wanted to know. All right, so that is how easy it is to get your calculator to find the median and the mean. And there's some other things in that screen that we're going to come back to. Now, how do you find the mean and median if you have a graph? Well, here is a histogram of how much money people spent at the drugstore. So 100 people were asked as they exited a drugstore, how much money did you spend? So for example, somebody said $20.03. So they would go into this bin right here, right? So these bins go 5, 7, 9, 11, 13. I skipped every other bin, but there's still bins there. So this bin is 19 to 21. So if you spent $20.03, you would be one of the 5 people that fell into this bin right here. Okay. Anyway, I digress. All right. So how do I find the mean of this data? Well, you can't. You can't. Remember, to find the mean, you actually have to know every single value. And with the histogram, I don't know every value. I know 5 people spent between $19 and $21. I don't know what they actually spent. I just know that they were in that bin. So unfortunately, I cannot actually calculate the mean. But this data is skewed right. We see that there's a large majority of data on the left to the smaller numbers, less and less and less and less and less data to the right. And you could even say that there potentially might be an outlier, maybe even more than one outlier, but this definitely looks like an outlier. Somebody spent between $43 and $45. Even these values could be outliers. They're kind of separated from the rest of the data. But again, when those outliers occur, the mean has to take them into account. So the mean is going to be a little bit higher. Now, again, we don't know what the mean is, but we could kind of get a feel for it. Now, the median, same thing. I don't have the individual values in front of me, so I can't actually find the exact median, but I can locate where it falls. This is super important. So remember that formula for the median. This is a formula to tell you not what the median is, but where it's located. So it's 100 plus 1, that's 101. 101 divided by 2 is 50.5. That does not mean the median is 50.5. That means that the median can be found at the 50.5 value. So right between 50 and 51 is where the median is going to fall. Value. So let's find those values. Okay, so now you gotta kind of count with me here, right? So we got 8 values in the first bin, plus 13 values in the second bin. So now we're at 21 values. Plus 11 is 32 values. Plus 14 is 46 values. Plus 22 is 68. Okay, so wait a minute. Here's the deal. Up to this point right here, there were 46 values. 8, 13, and 11 is 46. That means the 47th, the 48th, the 49th, the 50th, and the 51st value are all in this bin right here, right? Because if I go past this bin, now I'm at 68. And again, I'm looking for the 50 and 51st value because that's where the median is, right in between the 50th and 51st value. So I don't know what those values are. I truly don't. But I do know that whatever the 50th value is, it's in this bin. And whatever the 51st value is, it's in this bin, which means the median falls somewhere between $13 and $15. I, again, don't know what it is. Could be $13.22, could be $14.68, I don't know. But I know that that 50th and 51st value, right where the median is located, is somewhere in that bin. Now, one more comment I want to make is that remember, the mean is always going to go towards the tail. If there's outliers on one side, the mean's always going to get dragged that way. So again, I know the median is somewhere in this range from $13 to $15. The mean is more than likely going to be a little bit bigger than that. It's going to be a little bit bigger than that because it's going to get pulled to the right because of these few upper possible outliers. All right, here's another graph that we could practice this on as well if you'd like. Represents 500 people. So let's just, quickly figure this out, right? So I'm not going to do the full thing, but I'll walk you through it. So n plus 1 divided by 2 is going to tell me where the median's at. So we got 501, 500 plus 1, divided by 2 is 250.5. So I have to find the 250th and the 251st value. So again, I'm going to have to do a little bit of estimating here. Like maybe there's only 2 people here and maybe there's 5 here. So we would have to slowly figure out where that value is. But check this out. When you're so nice and symmetric, like this graph is, you pretty much know that the mean and the median are going to fall right in the center because they're evenly balanced. So my guess is that the mean and the median are both pretty close to 2,500. Maybe not exact, but they're both going to be pretty close to that because of the beautiful symmetry that's going on in this particular graph. Let's just take a look at a couple other graphs here. Again, when you're nice and symmetric, both the mean and the median are going to be smack dab in the center. When you're skewed left, think about this, the median doesn't care if you're skewed. The median just wants 50% of the data above it, 50% below it. So the median might be somewhere like right here where there's half and half. But because of the skewness, the mean is going to go towards the tail. The mean is going to be a little bit lower than the median. When you're skewed right, once again, the 50% mark, if I kind of try to cut that in half, the 50% mark is going to be right about there. That's the median. And then because of the skewness, the mean's going to be a little bit bigger than the median, if that makes sense. Now, when you're bimodal like this graph down here, once again, you got these 2 peaks, left, right peak. The mean and median are going to probably get evenly balanced and be pretty close to the center of that data. All right, what other statistics are there? What other numbers can we use to talk about our data? Well, here are a couple more. We have percentile, first quartile, second quartile, third quartile, min, max. Min and max are pretty straightforward. Min's the smallest value, max is the biggest value. Okay, but if you say, hey, 3 is the smallest value in my data, 3 is a number you're using to describe your data, makes it a statistic. But let's talk about a percentile real quick, because for a lot of you that might be a new term. So a percentile is interpreted as the value that has p% of data less than or equal to it. Okay, I know it's a little bit confusing, but let's use some examples. Examples make this a lot better, right? So if you're taking the SAT and you were told that your score puts you at the 85th percentile, what that means is that 85% of other scores were at or below your score. So that actually means you did pretty good. So that actually means 2 things. It means 15% of people did better than you. Oh well, deal with it. 85% did as good as you or lower. Okay? So again, the definition of a percentile is at or below. It's the percentage of data at or below. So the median is actually known as the 50th percentile because remember the median has 50% of data below it. It also has 50% of data above it because it's in the middle, but by definition, it's the 50th percentile because there's 50% of data below it. So again, a percentile ranking is basically ranking the percentage of data below your value. Now, we also have the quartiles. The quartiles are essentially very special percentiles. The first quartile, often called Q1, is the 25th percentile. It is the value that has 25% below it, a little quick math, 75% above. Q3 is the third quartile that has 75% below it, 25% above it. So think of Q1 as the middle of the bottom half of your data. So if I kind of like have my data in order, min to max. The median is the second quartile. The median has 50% below, 50% above. 50, 50. The middle of the bottom is Q1. the first quartile with 25% below it, 75 above. The third quartile is the middle of the upper half of your data, that's Q3, that has, again, 75% below it, 25% above. So just like quarters split a dollar into fours, quartiles split your data into fours as well. So the median is the second quartile right in the middle, and this breaks your data down into these 25% chunks. So that's why Q1 is defined as the 25th percentile, 25% below it. Q3, 75th percentile. Remember, the definition of a percentile is the percent of data below. Now, this also tells us that if we're looking in between Q1 and Q3, in between would be 50% of data. Kind of cool. All right, so how do we find percentiles and quartiles in data? Again, calculator is going to rule the roost here and do a lot of the work for us. So once again, remember, it's already on my screen. So again, I'll walk you through the process just real quick. Stat, edit, enter the data into any list, I don't care. Stat, slide over to calc. One variable stats, identify the proper list where your data is at. Leave the frequency list blank. Now, how cool is this? If you scroll down, there's Q1 and Q3. So we actually call this the 5-number summary. So the min, the max, the first quartile, the third quartile, and the median, second quartile, is called a 5-number summary. But they're all given to you. So if you have your calculator, you really don't have to do any extra special work to get these values. Even though you could do it by hand, but doing it by hand is not cool. I mean, it's cool, come on. But it just takes a while. All right, what about finding percentiles and a graph and quartiles and graphs? So once again, here is our data about the 100 people that went to the grocery store. And we asked them, or drugstore, we asked them how much money they spent. So again, here's what we just got to think, right? You know, it's kind of thinking, right? If I have 100 people, 50 are down here, 50 are up here, there's the median, the 50th percentile. So the first quartile is going to be, it's nice on this problem because it's 100, right? But with the bottom 50, you have 25 here and 25 here. So there's going to be Q1. So if I'm trying to figure out where the first quartile is, it's going to be right past the 25th value, right? It's actually going to be between the 25th and 26th value. Just like the median was between the 50th and 51st value, the bottom, the middle of the bottom is Q1 between 25 and 26. So again, where is the 26th value and the 25th value? So we got 8 and then we got 13. So now we're at 21. So in these first two bins, we got 21. And then I got 11. So if I go to 11, that now puts me at 32, which means the 25th and 26th value are somewhere in this bin. So that means the first quartile, Q1, is somewhere between $9 and $11. I don't know exactly what it is, but it's somewhere in that bin. And then I could do the same thing for the top, right? Because Q3 is splitting that top in half. So if I actually count from the top, 1, 2, 3, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, boom, the 25th and 26th value counting from the top are going to be somewhere in this bin. Don't know what they are, but they're going to be somewhere in that bin. So again, we could locate Q1 and Q3. All right, when we have a dot plot, it's kind of nice. So maybe I could say, okay, if my car gets 30 miles per gallon, what is my percentile rank? Well, you have to first count the total number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 total dots. Of those 16 dots, these are all at or below my car, which gets 30. That's 1, 2, 3, 4, 5, 6, 7. So 7 of the 16 dots are at or below my car, which means that I fall at the 44th percentile. It's actually 0.4375. So that's the 44th percentile. So again, why? Because that means 44% of the cars had a gas mileage at or below 30. So 30 miles per gallon is sitting at the 44th percentile. 44% of data is at or below it. All right, in the next video, we're going to continue on by talking about statistics that measure variability. So stay tuned.